Is this recording? Oh, okay. This is Tim Malloy, video 2-1 on capacitance. My pointer's not working again, so I'm just going to use the rose pencil. Okay, so the question reads, 4 capacitors are shown in the figure below. So 1, 2, 3, 4, and this fourth one equals 16 microfarads. So, just pretty simple circuit, I guess. And I guess, they might not show, but we can assume it's hooked up to a battery of some sort that, the circuit's completed. But anyways, question A asks, find the equivalent capacitance between point A and B. So they want us to turn this into just one big capacitor, which is, pretty simple as long as we remember our circuit rules for series and parallel capacitors. So this reciprocal rule, and then this just addition rule. So again, simplify the circuit. First off, I'm going to combine these into one capacitor so we can use the reciprocal rule. And the way I like to do this is just, never mind. I thought I was going to see something profound. Well, anyways, this side is, this simplifies to 19/48 microfarads, and then, so that total capacitance is 48/19 microfarads, because, we have to do 1 over. So here's what we got, and now I'm going to combine these two. And that should, just by the addition rule, that should get us 162/19 microfarads. And now we're left with a series, just like we had a series over there. So same rule, reciprocal rule. And then we get these two capacitors when added equal this 271/1620 number, take 1 over, and then I put it in decimal form, and we get 5.98 microfarads. So I'll just scroll down to the answer. That's all good. So that part is pretty simple. Kind of flew through it because it's just plugging in numbers, really. That's all there is to it. Just plug in the numbers in a formula. Okay, and then part B asks us to calculate the charge in each capacitor, taking change in voltage from A to B to be 16 volts. So I figured, okay, let's use our simplified capacitor from up here, and let's go throw it in our good old capacitance equals charge over voltage formula. Put in a number for voltage, put in our number for capacitor, and we're left with the total charge flowing throughout the system. And I thought it was important to write down our new charge and our new charge rules for series and parallel capacitors. So we have an equal rule or constant rule for series, and then a addition rule for parallel. And let me just scroll back up to this. So with the parallel, that's the addition rule. So we don't really know any of that yet. However, we do know that this part that's in series, that's just going to be the total charge. No addition rule or anything like that. It's constant. So the charge on the 20 microfarad capacitor is 95.68 microcoulombs. Okay. And then what I actually decided to do is solve for the voltage at that capacitor, because we know capacitance, that's all good. We know charge. So we do that, and then we get so the voltage on that capacitor is 4.784 volts. And so if we subtract, because we know the voltage rule is in series is just addition, so we get we understand there's 1.216 volts in parallel circuit. And remember, the parallel rule is constant in each branch of the circuit. So then I hopped on over to the 6 microfarad capacitor over here. Didn't want to mess with any of this stuff over there, just because a lot easier to play with one capacitor than 2. So where am I? Okay. We know we know voltage in that part in that branch. We know capacitance in that branch. So Then we get charge equals 67.3 microcoulombs for 6 microfarad capacitor. So this one is all good. This one is all good. Now let's go back to our charge rule for parallel. So in parallel, again, it adds together. So, okay, well, we have our total, and then we have our one branch. So if we were to just do subtraction, we would get 28.34 microcoulombs for the final two. And again, it is constant in this branch, so that is all good. Okay, all done. Good stuff. Check the answer. So my takeaways from this problem are that it was good quiz prep for I think it was the first quiz. Yeah, the other one we just took the first quiz, and then the first part of this oh shoot, this it first asks for the 20 microfarad capacitor's charge, which kind of tells me, okay, why don't we start with the 20 microfarad? Oh, it's in series. How nice is that? So I guess just try to look out for the simplest point to start. Hopefully they give it to you. What else? Remember to use all the available circuit rules, like how I brought in the parallel rules and whatnot, which was super important to remember. And I know the next part of circuits is incorporating current resistance back again. So we're gonna just remember, I guess remember voltage, remember current, resistance, charge, and capacitance. These are last year it was mostly just these three of them, right? And now we're going to include these two guys too. Okay, thank you for watching. I think that should be all.